Okay, college mathematicians, welcome to your first video lecture. Hopefully there won't be too many of these, but once in a while I do have to miss class um, today because I've got pink eye, I think, and you don't want pink eye. I don't know what the big deal is. It's not like it hurts a little bit, but whatever. So this is what I do for many of my classes, like my calculus classes. All the lectures are online, and then they watch lectures and try the homework at night. And then during the day, we work on, homework questions and stuff. So it works pretty well. So we're going to start out doing some problems from section 7.3. And I'll show you what I mean. And this is kind of how I do it here. Let's get the pen, nice black ink, medium thickness. So we'll start with section 7.3. And that is the distributive property, okay, in equations, like this. So a quick review of distributive property. Just so we remember what it is. It's something like this, where if I had 3 times 5 plus 2, right, if I were trying to distribute this. Well, order of operations, if I did it this way, I would do parentheses first, so I'd say 3 times 7, and that equals 21. Alternatively, I could distribute, which is totally okay. Just to check this out, and I could say 3 times 5 plus 2, and when I use this thing, for some reason I tend to get really multicolored. So here's, we'll do the 3 times 5 first. We'll do the multiplication here, which equals 15, plus, and then we multiply this guy here, and that equals 3 times 2 is 6. Oh, and sure enough, that equals 21. Okay, so the key thing to remember here is that when we have distribution going on, a number multiplied some parentheses, this number has to get multiplied by everything in the parentheses for everything to work out. So we have to distribute into everything. So that's very important to keep in mind. So I'm just going to jump straight into some examples here because 7.4 is going to take a little bit more work. So we'll talk about that then. Let's do an easy example. Let's say I have this one, solve 4 times x minus 5 equals 8. So I don't know what x is. I certainly don't know what x minus 5 is. So there's not much I can really do here inside the parentheses. So what I'll do is distribute. Again, I'll do that in orange. So I'll do 4 times x, and then I'm going to do 4 times negative 5. And so that works out to be 4x, and then this 4 times the minus 5, or 4 times, it's minus 4 times 5, so it's minus 20 equals 8. All right, now what do? I'm going to switch over to blue here. I want to keep all my x's over here on the left and get everything else over here on the right. So I'm going to add 20 to both sides. I'm subtracting 20 to undo subtraction. I add 20. And so now I'm left with 4x equals 28. Now many of you look at this and say, oh, this is a piece of cake. But just in case you don't, I'm trying to get x by itself still. What's going on with x? It's divided by 4. It's multiplied by 4. X is multiplied by 4 here. So to undo that, I'm going to divide by 4. So I'm going to go to blue again. I'm going to say divided by 4, because multiplication undoes or division undoes multiplication. Divide both sides by 4 so it stays equal. And I can say that x equals 7. All right. So that one's pretty straightforward. I've got another easy one here. Let's try this one. I'll make a little curvy line here to separate our problems. I think I can fit one more on this page. We'd say, notice I'm writing a little bit smaller to save room. I don't know why I'm saving room, and electrons are free. 4 times, whoops, no, we just did that one. Go up to my handy eraser here. Erase that. Back to the pen. 3 times 2x minus 1. Equals 3, like this. Well, how do we do here? We have to distribute again. So this equals, I'll write this a little differently, 3 times 2x minus 3 times, this is a times, not a subtract, 3 times 1 equals 3. So 3 times 2x is 6x minus 3 times 1 is 3 equals 3. So what do I have to do now? I have to add 3 to both sides, plus 3 plus 3, and that gives me 6x equals 6, and then that gives me, divide both sides by 6, divide this by 6, divide this by 6, and then I can say with certainty that x equals 1. Alright, so still pretty, oh, what am I doing here? I forgot to put boxes around my answers. Right, I pick on you guys about that, and now I forgot to do it myself. Next one. Look, they get a little harder now. So let's take a look at this one. -4. Oh boy, negative numbers. Times the quantity -3x plus 1 equals 8. Well, how do I approach this? I've got a negative number times some stuff in the fraction. Well, the same rules apply. We still have to distribute. So this -4 has to get multiplied by the -3x, and the -4 has to get multiplied by the +1. So we do that. It's -4 times a -3x plus a -4 times a +1. Get out of there. Equals 8. Now when I do these, a -4 times a -3x is -4 times -3 times x. Well, -4 times -3 is a +12x plus a -4 times 1. So I'm really adding a -4. So that's actually, I could write that as plus a -4 equals 8. But adding a negative number doesn't make a lot of sense, so I'm just going to rewrite this as 12x minus 4 equals 8. And then I can add 4 to both sides. Add 4 here, add 4 here. Why did I add that 4? To undo this -4. And then this becomes 12x equals 12, and we can kind of see where this one is going already. I didn't mean for these to be the same answer, but that's how it worked out. Divide both those by 12, and now we have x equals 1 again. And that's a coincidence. They don't all work out to be x equals 1, it's just these two did. Alright. So now we're going to get, well, let's do another -1 just to get those down. Let's do this one. It's negative 9 times 2x minus 3 equals 27. And then we can distribute. So I'm not gonna write out quite as much. It's negative 18x, and that comes from the negative 9 times the 2x. Negative 9 times 2x is negative 18x. Now I've got a negative 9 times a negative 3. It's multiplied. This negative 9 is multiplied by this stuff. It's not negative 9 minus 3. It's negative 9 times negative 3, which is plus 27. So it's negative 18x plus 27 equals, did I do this right? Yes, I did. Equals 27. So now what I'll do is I'll subtract 27. Oop, I didn't mean to do that. Subtract 27. Sometimes I feel like I wrote down half of one problem, half of the other, but this one is working out okay. So what is this? 27 minus 27 is 0. 27 minus 27 is 0. Interesting. Negative 18 times x, my unknown number, has to equal 0. Now this is something that gave some of you trouble on the test. Negative 18 times something has got to be equal 0. Well, let's divide by negative 18. And we'll divide by negative 18. So x equals 0 divided by negative 18. Well, 0 divided by anything. If I don't have any pizzas and I divide it into 18 pieces, I still don't have any pieces, right? There's nothing there. So x equals 0 in this case. All right. I feel like I'm working in dark blue there instead of black. Yeah. Okay. Now let's get into even a little harder problems. A little harder yet. And this one will be 6x plus 7 equals 3 times 2x plus 4. Now what's different about this one? Well, I don't know. It looks okay so far, but the distribution is over here this time. So 6x plus 7 equals this thing here, 6x plus 12. Now this one's a little interesting here. What's going on? Well, I've got x's here and x's here. It'd be nice to get all my x's on one side. So I'm going to subtract 6x over here, and then subtract 6x over here. So I get all my x's on one side. But now when I subtract these, I've got 0x, and 0 times x is just 0, plus 7 equals 12. Well, 0 times x is just 0, and then plus 7 equals 12. Well, wait a minute. 0 plus 7 is just 7. 7 equals 12? That can't be. So there is no solution to this problem. And sometimes that happens. There is no solution. So if we were to go up here and say, I need some number, whereas 6 times the number plus 7 is the same as 3 times the number, or 2 times the number plus 4. Well, it turns out there is no number where that works. That's impossible. So we can go all the way down here and say, let's do that in red since it's impossible. This is impossible. Okay, so that's what happens when there's no solution like that. Let's try another one that might work out a little bit better, but still in the hard category. How about 8? Ooh, that's a rough 8. 8 minus 3 times the quantity x minus 2 equals x minus 6. Okay, well, here again we have to distribute. Now, this distribution is a little tricky too, right? These are all in the little harder yet category. We're subtracting this whole thing. So this whole blue box, all of this is subtracted. So I have to take away not only the 3 times x, but I have to take away also the 3 times the negative 2. So what's going to happen here? The distribution gets tricky. So I have 8. Oop, got to make it a little thicker ink here. I have, again, I'm struggling with my 8s on this problem. 8 minus a 3 times x, and then minus a 3 times a negative 2. Boy, there's a lot of minuses. I mean, minus a 3 times a negative 2. Wow, okay. Equals x minus 6. So, let's try this. So then we know this is still 8, or my first good 8 of the problem. 8 minus 3x minus a negative 6 equals x minus 6. Whew, wow, what a mess. Well, I know that a minus, that is the same as a positive. So, 8 minus 3x, and then minus a negative 6 is the same as plus a 6 equals x minus 6. So now what I'm going to do, this is a huge mess, so I'm going to start to do what we call this collecting like terms, right? I've got an 8, and then we'll just skip this minus 3x for now, and we'll just look at the plus 6. So I'm going to say this, the 8 and the 6 is a 14. And I'm going to take away 3x, and that equals an x minus a 6. But now I'm back to the same problem where I've got x's on both sides. And it sure would be nice to get all my x's onto one side. Since I'm taking away 3x's here, I don't like the negative numbers so much. So I'm going to try to get rid of this 3x and move it over to here. So I'm going to add a 3x. Now I don't know what x is, but I'm going to add 3 of them to this side. Well, that's right, because I'm also going to add 3 of those x's over here. Even though I don't know what x is, I can still add it. And then we come to here and we say, all right, 14, and then the minus 3x plus 3x, that goes away. X plus 3x is 4x minus 6. Holy cow, I'm still not done. I'm trying to get x by itself. So I need to add a 6 to both sides now. All right. So now I can barely fit this on one page. It's such a long problem. So I'm going to add 6 over here. That makes that a 20 equals, and then all this cancels out here. So let's cancel those out in red just so you can see what happened. Those cancel. And then I'm left with 20 equals 4x. So 4 times this number equals 20. Well, what does that mean? That means that x must equal 5. So that was very fast, but a very quick review of distributive property and how to use a distributive property when you're solving equations. And we'll spend a little bit more time on 7.4, where we're doing fractions. I gotta remember how to pause this here. Pause. Stop.